record this. All right, so and now I want to just review the problem that we did last week, kind of get us back, into thinking about how this works. And then I'm going to send you off into groups to work on a problem. And then when you come back, we'll do the problem together, and remind me to record then. Okay. So I just want to make sure I get everything on tape here from the class that's important, without like 10-minute blocks. Okay. 10-minute blank spots. So this let's actually kind of, yeah, let's do this. Let's erase this right here. Yeah, this was the function that we were dealing with right here in the box. Okay, and it's a piecewise function, which is basically telling me that over different parts of the domain of this function, I'm going to apply different rules. When I have my x's less than 0, the rule to this function that I'm going to apply is y equals x squared. Where x is 0, I'm going to apply, well, y is 2. And where x is greater than 0, I'm going to apply x plus 2. Y is x plus 2. So if I was looking for specific points on this function, like it said here, find f of -2. Well, the first thing I need to do, we know that this is my x value. So I got to look here and say, well, which one of these spots here has -2? And I see it's this spot, which means I'm using this part of the function to find the value. I determined the domain of this function by making a number line. Not sure where I did that. But I determined the domain of this function by making a number line for each of these pieces here, where it says if. This is where I'm making the number line from. These are the domain pieces. Everybody see where I'm circling? Yes, you can see what I'm saying? Yeah, okay, great. So if you graph on a number line each piece, your domain is wherever that line, wherever there's at least one line. There would be, yeah, okay, I'm gonna leave it at that. And then when I graphed it, which I did on this slide here, the way I like to do it is I started out at the top and I first graphed the graph of x squared, but then erased everything that wasn't x less than 0. So I had my x squared graph, which looked like that, the whole thing in blue. But then I saw that my domain was only where x is less than 0. So I just got rid of that part, the part where x wasn't less than 0. And I did that for all 3 sections. And then the last thing that I did was I used the graph to find the range of the function. So what are all the y values? And this one turned out there were no gaps in y values, because they're y values all the way from 0 to infinity. But they did start at 0 and they went up to infinity. So there was the range of that function. All right, are we feeling like we could try this in a group with a different function? Yeah, we can try it. Okay, use the whiteboard and help each other. So I'm going to send you off into groups, and I'm going to email out the first problem. The first problem looks like this. Let me just make sure that we're okay with it. So the first problem looks like this. Only 2 pieces to this piecewise function. Okay. 2x plus 4 and negative 1/3 x plus 4. So you should recognize both of those as linear functions. They'll be lines. So I'm going to send you off to do it. You don't need to write it down because I made it on the it's on the PDF that I'm sending out to you. So I'm opening up the rooms and I will email you. I'm going to be gone for just a minute, but I'll be back. And when you're done or when you are stuck, well, when you're stuck, call me and I'll see if I can help you. But then if you're totally stuck, then just come back to the main room. Okay, got it? Everybody clear? Yeah. Okay. All right. Off you go. Piecewise 1. Zoom recording. See, I'm so good at remembering today. I can't believe it. There we go. So let's kind of talk about how to do this one here. Let's see here. Okay. So it was very interesting to me because all of the groups asked the same question about, well, you didn't give us any points. You know, like in the first problem, it said find, f of -2 and f of 0 and f of something else, right? And you're right, I didn't give you those points. This was really designed to just kind of get you used to the idea of what this domain thing meant. But in terms of graphing this, well, I can graph this as a line. I know that y equals mx plus b. And so this is my slope. And b is my y-intercept. So I would start with 4 because that's my y-intercept. And then I can see my slope is 2. So that means up 2 over 1. Up 2 over 1, or over 1 down 2. And from there, I can put together a pretty good line. I'll try my best to put together a pretty good line. And this is a pretty good line. Yeah, so there is the graph of 2x plus 4. But it says if x is less than 1. So I say, okay, well, all these x's here that are greater than 1, I can't use those. So really, I have here an open circle because it's less than 1. And so this is the graph of my first piece. Is everybody clear on that? Is there a question on that? Come on, ask out, speak up. Yes, we're good. Thumbs up, thumbs down. Mia, please.
Okay, so for the open circle, can you explain that part again?
Yep, because it's saying if x is less than 1. So I go down here and I'm looking at my x values. Here's 1, right? And so I erased all of these over here, right? So I got rid of all this part of the graph. But where x is equal to 1, it says, no, I only want it to be less than 1. Now, okay. So a very common mistake, listen carefully. A very common mistake is to say, oh, well, it says x less than 1. So that means I start the graph here at 0. How many people did that? Okay. Now, I'm going to ask you a question, Mary Rose, since you're being honest. Is 0.9999999 less than 1?
Yeah.
It is, right? So that's why I got to go all the way up almost to 1. I just put an open circle here at 1 because, oh no, I'm the wrong spot, sorry. It was 1, 6. Because anything less than 1, which includes all these points between 0 and 1, those are all good points. Those are all less than 1. Those are still included in my graph. Mia, was that your question?
Yes, thank you.
You were thinking integers just like Mary Rose, huh?
Mm-hmm.
Yeah, don't think integers. All right, less than 1 means 0.99999999999. I can go on forever, right? Because a point is just a little tiny. Well, a point doesn't even have any dimension, but we won't go there right now. Okay, so I got my first piece of the graph. Now my second piece, well, again, it says I have a y-intercept of 4. Wait a minute, I don't want that color. I want a different color. A y-intercept of 4, a slope of -1/3, and this is for x greater than or equal to 1. So I'm going to start right here at x. My y. Okay. Glenn, think through carefully. Okay, I'm going to graph the whole thing, and I'm going to start right here at my x-intercept of my y-intercept of 4. So the graph would be here, and then a slope of -1/3. So that would mean down 1/3, down 1/3, or kind of over 3 that way, over 3 that way. So I have my line right here that I can see. But it's telling me only if x is greater than or equal to 1. So I have to do some erasing here. I have to erase all of this stuff right here. I actually have to erase it right there, 4. And I'm not starting until x equals 1. And here I have a closed circle because 1 is included in the domain of this piece of the function. Am I making sense? Are we doing okay with this problem? We're doing okay. Somebody asked me a question. No, we're you sure?
I have a question, but I'm not exactly sure how to ask it.
Okay, try.
Yeah, so the first one is x is less than 1, and the second one is x is greater than 1. So why is it at the same point? Like, wouldn't one of the ones be on the other side of the graph?
Ask it again, Brooklyn, one more time.
If the first one's x is less than 1, and the second one is x then greater than 1.
Yeah.
So the points where you have the open and the closed circle, wouldn't one of them be on the opposite side of the graph? Because it's greater than and less than. I don't know.
Okay, so let's I understand what you're saying. I'm gonna take a little tangent here, and let's, instead of doing a graph like that, let's do a number line. Is that okay with you?
Sure.
And if I say x is greater than 1, then I start here and I go that way. Are you okay with that?
Yeah.
But if I say x is less than or equal to 1, then I start here at 1 because, right? And I go that way. It's not saying less than or equal to -1. It's saying less than or equal to 1. Brooklyn asks, am I making sense here?
Yeah, I mean, I guess I thought they were different, but they're not.
Because this is saying start here at 1, but go positive because it's greater than 1, right? And this one over here is saying start at 1, include 1, but go negative because I want everything that's less than 1. So if I kind of go back to my graph here, that's what I did. This 2x plus 4, it says start this graph kind of where x is equal to 1, but don't count 1, and then have the rest of the graph like that. And this one here says, yeah, start at 1, include 1, but have the rest of the graph that way. And that makes sense. Yes. Okay. Pretty good? Everybody good with this? Okay. So now we have to give the domain and the range of this function. So for the domain of this function, well, I think I'll use my number line trick again here. Okay. So I'm going to make a, well, actually, I just did the number line. No, let's do it again. Because I did it wrong. 0, 1, 2, 3, 4, 5, -1, 2, 3, 4, 5. Well, the first domain, my green domain here says x is less than 1. So I start here at 1 and I go less than 1. And my second domain, which was purple, says x is greater than or equal to 1. So I include 1 there and I go this way. Well, it looks to me like I'm starting over here at -infinity. And I go all the way over here to 1, and the green one stops, but the purple one picks it up. The purple one includes 1, and then it goes to infinity that way. So my domain is -infinity to infinity. That is my domain of this function. Is that clear? Maria?
Could you repeat that one more time?
Yeah. So the first strip of the domain says x is less than 1. That's my green part, okay? So x is less than 1. You're good with that, right? Okay. So I start here at 1 with an open circle because it doesn't include 1. And I say, so the domain of this piece is going all the way negative because everything is less than 1 that way. Then the second piece said x is greater than or equal to 1. So I say, okay, I can graph that. And I start here again at 1 and I go positive because all these x's are greater than 1. Still good? Okay, so now I'm looking, well, what x values then are included in this function? Well, I'm starting over here at -infinity because this green line is going, like way over that way forever, right? And I keep going, and then I'm getting close to 1, and I get to 1, and I say, oh, wait a minute, the green one stops there at 1, but the purple one starts at 1 and includes 1, right? And then that one goes to infinity this way. So I don't have any gaps really in the domain here. It goes from -infinity all the way to infinity. Got it? Right? Everybody good with that? Good. All right. Well, now let's look at the range. The range of this is going to be a little bit confusing. I'm just telling you. Okay. So the range of this. Well, both of these graphs are going downward. Everybody can see that? They're both going downward. So there's a certain point at the top where none of the graphs are at all. And that to me looks like y equals 6. That is my highest y value. Oh, but wait a minute. Stop. Rewind, delete. Okay. Because domain we write from lowest to highest, right? So my lowest y value is clearly negative infinity, because both the green and the purple are going straight to hell. They're going all the way down. They're never stopping, right? So my lowest y value is negative infinity. Now, my purple graph, it went down here from where the devil lives up to, this is actually like 3 2/3 or something like that. I don't know, something like that. And it stops. But if I keep looking at now the green graph, the y values they pick up there and they continue all the way until I get to 6. But there's an open circle there where y equals 6. So the range is negative infinity to positive 6, but not including 6. What's confusing in that is this segment right here. If you're looking at it just with your eyes, it looks as if there's a gap, but there is no gap. There are y values in the green one here that are covering that gap. So those y values are part of my range. Yeah, Maria.
So if there were a gap, would that mean that we'd have a union?
That's exactly right. If there were a gap, then you would have a union. All right, how do we feel? Pretty decent? Okay. Yes? Okay, well, let's press go to do some more. This one a little bit more complicated. You know what? I have a better idea. I want you to do another one that's linear, just so that we're on top of it here. Okay, so I have to make it up, which is always dangerous when I make something up on the fly, but we're going to try it. So I want f of x is equal to, and then I'm going to put a bracket. 3x plus 2 if x is greater than 3, and negative x plus 1 if x is less than 2. Yeah, this is a good one. I like this problem. I think this is going to be good. All right, everybody got that written down? Yes, and I want you to graph it and give me the domain and the range. All right, I'm going to send you back out into your breakout rooms. You can work on that together. I'll send this out again too. Stop share. Let's pause. Okay, welcome back. Did anybody finish? Yes, you did. Almost. A little bit. Okay, let's just go over it. Let's go over it. And once again, I remembered to record this. I can't believe how. Must be because I got like 8.5 hours sleep last night. That was pretty good. 8.5 hours sleep, man. 8.5 hours sleep is awesome. Okay, so well, let's see here. You know, I have a little problem in that my graph paper is maybe too big, but it's okay. We'll try it. So let's make an XY axis. Here's a Y axis. Here's an X axis. Oh, that looks kind of okay. Okay. So my first one is 3x plus 2. All right. So I know I have a y-intercept of 2 and a slope of 3. So 1, 2, 3, probably here, and then, yeah, right about there, and 1, 2, 3, and over 1. So like there, kind of, maybe it's up here, I can't tell. No, it's up there. Right, so my line, let's go this way here, over 1, down 3. Okay, so my line looks kind of like this. Yeah, that's not bad. That's a pretty good line. But this is for x is greater than 3. Oh, see, I made this not so great. So that actually would start up. I thought this is the danger of doing the problem on the fly. But it starts over here, way up here someplace, probably at the point C, x is greater than 3. Then this would be the point 9, 11. This would be the point 3, 11 is where that would start. Is everybody okay with what I just said? Yes, okay. And that means that basically, you know, I'm sorry, but we have to do this proper. I need another page. I need to look at what's in here. Let's try this one. Oh, this will work better. Maybe. We'll try it. So it was here is the point. It was 3x plus 2, x greater than 3. So I know I have my intercept there at 2, and then a slope of 3, up 1 over 3. No, up 3 over 1, up 3 over 1, up 3 over 1. And so my line is looking, let's do one more, up 3 over 1. So my line is looking kind of like this right here. But it's only for x greater than 3. So that means I need to erase all of this right here. Okay, and it's greater than, so I have an open spot right there. And this is the point 3, 11. And now that looks better, yes? Everybody got that? Good. Okay, then what was the second piece? The second piece was negative x plus 1 if x is less than 2. Negative x plus 1. So I have a y-intercept of positive 1. And then negative x. I totally messed this one up. Because that would look like this, wouldn't it? Did we get that? Yeah, okay, so what's my mistake here? Oh, there's a great mistake here. What's my mistake? This is what I get for doing a problem on the fly. Come on, what's the mistake? Big mistake, big mistake.
Well, now there's space in between both of them.
There is space in between both of them. That is a fact. And that's what I was trying to get at. But in doing that, I made a mistake. Nobody sees it?
Is it because they're both on the same side?
You're very close. This is not a function. Doesn't pass the vertical line test. Does it? Do we see that? This does not pass the vertical line test. This is not a function. Bad, Mr. Jenkin. Bad, Mr. Jenkin. Yeah. All right, but the reason why I wanted to do this was I wanted you to see that the range here was going from negative infinity to 1, and then I would have to do a union 3 to 1 bracket, 3 to infinity. because I have this big gap right here. I'm sorry, no, not 3 to infinity. Boy, Mr. Jenkins, you're totally botching this. 11 to infinity. Because this is my y value. So I had this big gap right here that I had to join together with this union. You follow what I'm saying here? Is there a question? Yeah, Mia, please.
Wait, that's the range, or
That's
was
the
that,
range.
would the domain be similar?
The domain for this is not a function, but the domain would be from 0, which would be my lowest x value here. Do you see it?
Oh, wait, why are they included? Why is it included?
Why is it
With the
included?
bracket.
Because my blue function was come on, Mr. Jenkins. Oh, it shouldn't have been. This is a totally botched problem. Yeah, I'm sorry. I'm getting a better problem. We'll do it when we come back on Wednesday. Okay, I want you guys to have some practice with this. So it's not totally botched. It shouldn't have been included, Mia, because both of them are less than. So I'm like, I was messing the problems up. So rewind, delete like half of what I said, and there's still some good concepts here, but we'll do more of this on Wednesday. I told you there's a problem when I do stuff on the fly like this. Yeah. All right, go. See you later. Sorry for keeping you a couple.
Thank you.
You're welcome. Bye.
Thank you.